Hi, welcome to my channel. So now in this video, I would like to present about Gaussian density function, which is very important for a communication student. So I have one random variable x, and this random variable x is said to be Gaussian. It is called Gaussian only when it has its density function f(x) of x is equal to 1 by root of 2 pi sigma x square e to the power of minus x minus ax whole square divided by 2 sigma x square. So now here sigma x is called standard deviation, which is greater than 0, and ax is the mean value, and it lies between minus infinity to plus infinity, and we will discuss about these two in the coming videos. And here you can take the two as constants, real constants. Okay, this is Gaussian distribution function, and when you take Gaussian distribution function, it will be f(x) of x, which is given by 1 by root of 2 pi sigma x square, and you can take the property relation between f(x) of x and density function, which will gives you integral minus infinity to x e to the power of minus x minus ax square divided by 2 sigma x square dx. Okay, so these are the two equations which defines Gaussian density function and Gaussian distribution function for a given random variable x. Okay, so if we take the graphical representation of this Gaussian density function and Gaussian distribution function, I'm taking the first one as Gaussian density function. So if I'm taking x values on the x-axis and the density function f(x) of x on the y-axis, and this Gaussian density function will have maximum value at the value ax, at ax the mean value, and the maximum value is taken as 1 divided by root of 2 pi sigma x square. And with respect to standard deviation, x minus sigma x and ax plus sigma x, we are going to have the value of this function as 0.607 divided by root 2 pi sigma x square. So this is the Gaussian density function graphical representation. Okay, and if you take the same for distribution function, so there you will take this graph. So you can simply take this value. So like this. So where at ax ax you will have 0.5, and the maximum value achieved is assumed as 1, and with respect to standard deviation, ax minus sigma x and ax plus sigma x. So this is taken to be 0.841, and this is taken to be 0.159. Okay, so this is the graphical representation for Gaussian distribution function. Okay, and this Gaussian density function is also called normal density function, normal density function. And generally, these Gaussian distribution functions or Gaussian density function can be evaluated by using simple numerical approximations. So you can take some numerical approximation methods. We will discuss in the coming topics, coming videos. Okay. And when you take the applications of this Gaussian distribution function, so majorly in any telecommunication system or any communication channel, we are going to suffer communication channel. We are going to face noise interference, and this noise behavior is identified by Gaussian density function only. So simply you can take Gaussian noise, and by knowing the behavior of the noise using this Gaussian density function, you can able to eliminate this noise from the communication channels. So not only in the communication, in any electronics and communication systems, the distribution of noise signal, either it is internally generated or externally added, is exactly matched with Gaussian density function. And this generated or this existed noise can be removed or eliminated by knowing its behavior using this Gaussian density function only. Okay, so this is very important application of the Gaussian density function, and it is also very important for an ACE student to know about this Gaussian density function and Gaussian noise. Okay, and let us discuss about the very important topic of the Gaussian density function, which is taken as normalized Gaussian distribution function. Normalized Gaussian distribution function. So already we have Gaussian distribution function. And how to get this normalized Gaussian distribution function? If the Gaussian distribution function has the mean value, which is taken as AX is equal to 0, and the standard deviation sigma x is equal to 1, then the resultant function is called normalized Gaussian distribution function. Okay. And now just substitute Ax is equal to 0 and sigma x is equal to 1 in the already existed Gaussian density function. So then you will get normalized Gaussian distribution function. So when you take the original Gaussian distribution function, it is taken as fx of x is equal to 1 by root of 2 pi sigma x square integral minus infinity to x e to the power of minus x minus ax whole square divided by 2 sigma x square dx. So this is the Gaussian distribution function. Now I'm going to substitute ax is equal to 0 and sigma x is equal to 1. So then what is going to happen here? It will be 2 pi root of 2 pi only, sigma x is equal to 1, and the integral minus infinity to x e to the power of minus x. Ax is equal to 0. So this is going to be x square by 2 dx. Simply I can write this expression as 1 by root 2 pi integral minus infinity to x e power minus x square by 2 dx. But here I am going to make some small modification here. This is Gaussian distribution function. Now I am taking the conditions of ax is equal to 0 and sigma x is equal to 1 in this Gaussian distribution function. So the resultant one is taken as normalized Gaussian distribution function, which is represented as f of x. So this is normalized Gaussian distribution function. So simply I can write this one as f of x minus infinity to x equal minus x square by 2 dx for x greater than 0, for greater than or equal to 0, and for x less than 0 the same can be expressed as f of minus x is equal to 1 minus f of x. F of minus x is equal to 1 minus f of x. So this is the equation. So now how to evaluate this distribution function and how to what are the approximations we need to follow to simplify and to get the final equation or final value of this normalized Gaussian distribution function. We need to discuss about all these things. Now I am taking the original Gaussian distribution function, that is fx of x is equal to 1 by root 2 pi sigma x square integral minus infinity to x e to the power of minus x minus ax whole square divided by 2 sigma x square dx. So now for simplification purpose, I am taking let u is equal to x minus ax by sigma x and differentiating on both sides, then you are going to get du is equal to dx by sigma x. Ax is a constant, so you can get the value as 0. So dx by sigma x. So from this, you can take dx is equal to sigma x into du. So now I'm substituting this value here in this equation. Therefore, fx of x is equal to 1 by root 2 pi sigma x square integral. By substituting the limits, you can modify this as minus infinity to u to the power of minus u square by 2, because you are taking x minus ax by sigma x is equal to u. So now I am taking that simple modification. So then it is going to be e power minus u square by 2 into dx is replaced by sigma x du. Okay. So now 1 by root 2 pi sigma x square root of sigma x square becomes sigma x only integral minus infinity to u minus u square by 2 sigma x du, and sigma gets cancelled. Therefore fx of x is equal to 1 by root 2 pi integral minus infinity to u e to the power minus u square by 2 du. Okay, but as per the definition of normalized distribution function, if you see this expression, so as per the definition of normalized Gaussian distribution function, 1 by root 2 pi integral minus infinity to x e power minus x square by 2 dx is taken as f of x normalized Gaussian distribution function. So based on that, I am taking this as fx of x is equal to, sorry, simple modification here. I can take this as and this can be taken as f of u, or I can simply take this as fx of x is equal to f of u is equal to f of u is taken as x minus a x by sigma x. Okay, so this is the very important relation. Okay, so the normalized Gaussian density distribution function is given by fx of x is equal to f of u, that is equal to f of x minus ax divided by sigma x. Okay, so this is the relation between normalized distribution function and Gaussian distribution function. And now how to simplify this? So the function f of x, which is taken as Gaussian normalized Gaussian density function distribution function, is evaluated by using Q function approximation. Q function approximation. And for this, we have one relation which is taken as f of x is equal to 1 minus q of x. So here q is taken as q function, which is 1 by root 2 pi integral x to infinity e to the power of minus x square by 2 dx. Okay, and the approximation for this qx is an integral function. So for this, an approximation is suggested by Professor Borgeson and Sundberg. Approximation for q function is q of x is equal to 1 divided by 1 minus a x plus a root x square plus p e to the power of minus x square by 2 divided by root 2 pi for x greater than or equal to 0. So this is the approximation given for q function. So here a and b are constants. A and b are real constants. And at the same time, and this approximation has found to give minimum absolute relation error for any x greater than or equal to 0 when a is equal to 0.339 and b is equal to 5.510. And by substituting the values, the q approximation is given as q of x is equal to 1 divided by 0.661x plus 0.339 root of x square plus 5.551 e to the power of minus x square by 2 divided by root 2 pi for x greater than or equal. And now we will discuss about one problem based on this. So here a Gaussian random variable x is given with mean value ax is equal to 4 and the standard deviation sigma x is equal to 3. And they are asking to find out the probability of the event x less than or equal to 7.75 and write down the function, which is Gaussian distribution function, and draw the graph. Okay, so now for this given problem, ax is equal to 4 and sigma value is 3, and they are asked to find out probability of x less than or equal to 7.75. So I can write this simply fx of 7.75. As per the relation between Gaussian distribution function and normalized Gaussian distribution function, I can write this as fx of, you can see the relation between the two, that is here fx of x is equal to f of x minus ax by sigma x. So based on this, I can write this fx of x is equal to f of x minus ax divided by sigma x. So based on this relation, I can write down fx of 7.75 as f of 7.75 minus ax value is 4 divided by sigma value is 3. And by simplification, the probability of x less than or equal to 7.75 is equal to f of 1.25. And we need to find out this f of 1.25 by using the q function value. So now by using q function approximation, f of 1.25 is equal to 1 minus q of 1.25. Okay. And again, I'm using q approximation method. So which is, I'm writing again this equation, f of 1.25 is equal to 1 minus q of 1.25. So using q approximation equation, I am writing this as 1 by, so as per the formula, 0.661 into x value here is 1.25 plus 0.339 root of x square means 1.25 square plus 5.51. You should remember this approximation equation to solve the problem. Into e power minus x square, that means 1.25 square by 2 divided by root 2 pi, and this is valid only when x greater than or equal to 0. So here x value is 1.25, so automatically it is greater than or equal to 0. So you can take this approximation without any doubt. And by simplification, so by simplification the value is going to be 0.8944. Therefore, for the given problem, the probability of x less than or equal to 7.75 is 0.8944. Okay, so the first problem is completed, and the next one is we need to get a mathematical equation for this Gaussian density function, and you can also take Gaussian distribution function. So the required Gaussian density function, the required Gaussian density function is, so generally the equation is taken as fx of x is equal to 1 by root 2 pi sigma x square e to the power of minus x minus ax whole square by 2 sigma x square. So just to substitute sigma x value and ax value as per the given data, then you are going to get 0.133 e to the power of minus x minus 4 whole square by 32. So this is the required mathematical equation for Gaussian density function. So with respect to this, we need to draw the graph, and I'm taking a graph also, graphical representation. So the default model of Gaussian distribution function is looking like this. Okay, and it's going to have maximum value at the mean or ax. So what is the maximum value of this equation? This is 0.133. And you can also take 1 by root 2 times. So the value is here 4 and x minus sigma x, ax plus sigma x. Okay, and this value is 1 and this value is 7, and the value is going to be 0.0685. So this is the graph representation what they asked to draw in the problem. Okay, so this is about Gaussian density function. So we will solve some more example problems in the next videos. Thank you for watching.